The Dhruv helicopter, named after the Sanskrit word for firm or unshakable, has a development history marked by both innovation and hurdles. Hindustan Aeronautics Limited, HAL, announced the Dhruv program in November 1984. It aimed to create a utility helicopter for India's defense forces. The Dhruv's development stretched over 8 years due to several factors. The Indian Army requested design modifications, and budgetary constraints also played a role. Additionally, sanctions imposed after India's 1998 Pokhran-I nuclear tests likely caused delays. Despite the challenges, the Dhruv prototype took its maiden flight in August 1992. Finally, after almost 18 years from program initiation, the Dhruv entered service with the Indian Coast Guard in March 2002. The Indian Army, Navy, Air Force, and Border Security Force followed suit. By 2007, over 75 Dhruvs were delivered to the Indian Armed Forces. The program targeted a production rate of 40 helicopters annually. Dhruv is powered by Turbomeca Shakti, also known as the Ardhadan 1H1, isn't quite a twin engine itself, but rather a turboshaft engine specifically designed for powering twin-engine helicopters. This engine is developed collaboratively between Turbomeca, now Safran Helicopter Engines, to France and Hindustan Aeronautics Limited, HAL, of India. But first let's just know what is a turboshaft engine. A turboshaft engine is a type of jet engine optimized to produce shaft horsepower rather than jet thrust. Unlike turbofan and turbojet engines that propel aeroplanes forward with a powerful exhaust stream, turboshaft engines are designed to spin a shaft that can be used to power various machinery. Just like any jet engine, a turboshaft engine starts by sucking in air through a front inlet. The air is compressed by a series of rotating blades in the compressor section. This compression significantly increases the air pressure and temperature. The compressed air then mixes with fuel and is ignited in a combustion chamber. This burning process creates hot high-pressure gas. The hot gas spins a turbine section, which is essentially a wheel with airfoils. This turbine section extracts energy from the hot gas. In a turbofan or turbojet engine, most of this hot gas is then expelled out of the exhaust nozzle, generating thrust. However, in a turboshaft engine, a significant portion of this energy is used to spin a separate shaft connected to the turbine. This shaft is what provides the rotational power for other applications. The remaining hot gas exits the engine through the exhaust nozzle, but it produces much less thrust compared to a turbofan or turbojet engine. Shakti emerged in response to a requirement for an engine with more power than the existing TM3332B2 used in some Dhruv variants, which, enabling better performance in hot and high-altitude conditions crucial for India's diverse terrain. This engine converts the energy from hot gases produced by burning fuel into shaft rotation to power the helicopter's main rotor and tail rotor, and a single Shakti engine provides enough power for twin-engine helicopter configurations like the Dhruv and Light Combat Helicopter. This engine is very beneficial for us because it simplifies maintenance and reduces ownership costs. The advancement in this variant incorporates innovative features like single crystal turbine blades and special coatings for durability and efficiency, and full authority digital engine control, ensuring optimal engine performance and efficient operation. The HAL Dhruv has evolved into several advanced variants to cater to specific missions, and the first one is ALHMK1, the base variant for utility roles. ALHMK2 features an advanced cockpit display system for enhanced pilot situational awareness. ALHMK3 is an upgraded variant of the base Dhruv with a focus on improved performance and operational capabilities. Key features include more powerful Shakti engines for enhanced power output, especially at high altitudes. Improved avionics suite for better pilot situational awareness and navigation. Increased payload capacity for carrying more troops or equipment. Advanced Self-Protection Suite for better survivability in combat zones. ALH Mk4, originally intended for the Indian Army, the HAL Rudra, formerly known as Dhruv WSI Weapons Systems Integrated, is an assault version. The prototype, which was given the go-ahead in December 1998 and made its first flight on August 16, 2007, was equipped with a 20mm turret-mounted gun in addition to anti-tank and anti-aircraft missiles. The Dhruv WSI will be able to perform anti-submarine warfare and combat air support missions. HAL is creating the light combat helicopter for the Indian Armed Forces, which is based on the Dhruv, in addition to the Dhruv WSI. It has stub wings that let it carry for air-to-air missiles, 8 anti-armor missiles, or 4 pods filled with 68mm or 70mm rockets. In addition, the LCH will be equipped with a target acquisition system with thermal vision and a laser rangefinder, as well as forward-looking infrared and a charge-coupled device camera. When the extreme vibration of the tail rotor was found to be the cause of a Dhruv crash landing in 2005, the whole fleet was grounded. Soon after redesigning the vehicle with new materials and revised design principles, Dhruv underwent recertification and was back in service in March 2006. The Dhruv was one of 4 focus areas that the Indian Committee of Defence identified as having significant export potential in a study that was issued in April 2007. Customers expressed interest in such a capability. Therefore, in January 2011, HAL and partner Israel Aerospace Industries revealed that they were working together to develop the Dhruv to function as an autonomous marine helicopter. On February 7, 2011, at a ceremony held at HAL's helicopter division, the 205 Aviation Squadron, headquartered in Leh, received the first 5 production Dhruv Mk3s. A HAL and Canadian developer CAE Incorporated created the Dhruv simulator that was certified by India's Directorate General of Civil Aviation in July 2011. The simulator may be readily adjusted to replicate several Dhruv variations and other helicopter models, including the Eurocopter Dolphin. In August 2010, the IAF ordered the creation of an oxygen life support system for the Dhruv, which Defence Bioengineering and Electromedical Laboratory has been working on to improve the helicopter's performance at high altitudes.